Here we're supposed to find the intervals on which the function is increasing or decreasing. All right, so we know that we're going to find the derivative, which is 1 minus 2 times the derivative of cosine, which is negative sine of x. The y prime is equal to 1 plus 2 the sine of x. And we're looking on the interval from 0 to 2 pi. Okay, so in order for me to find the intervals where the function is increasing or decreasing, I'm going to have to find the critical numbers. Critical numbers mean that I would need to solve this equation. I'm going to add or subtract 1 from both sides. I get 2 the sine of x equals negative 1. The sine of x is equal to negative 1/2. Any questions so far? Okay. So, question is, where is the sine of x equal to negative 1/2? Remember the little table that I showed you, a little quick table to find sine and cosine? Sine of x, cosine of x. We know pi over 6, pi over 4, and then pi over 3. 1, 2, 3, 3, 2, 1. Divide everything by 2 and take the square root of your numerators. So I know at sine is equal to 1/2, positive 1/2 at pi over 6. Well, it's equal, sine is negative here in quadrant 3, and sine is negative there. So what I want to do is I want to find the angle that corresponds to pi over 6. So that would be the angle here. This would be plus pi over 6. So that would be the angle 7 pi over 6. If I add pi over 6 to pi, that's going to give me 7 pi over 6. That would be the reference angle right there. So that's what I know. X would have to be equal to 7 pi over 6. That's one value. Another value will be right here. Whatever that angle is. I know that right here it's 2 pi. If I subtract pi over 6 from 2 pi, let's see, that's going to be 12 pi over 6 minus pi over 6, which gives me 11 pi over 6. So these are the two values on this interval that will give you, these are the two critical numbers, I should say. What do you think about that? Make sense? Alright, so now that we have the critical numbers, let's see if we can set up our test intervals. Our test value. Then we need to find the sine of our derivative. And then we need to come to some conclusion. Our intervals in this case, because it gives us an interval from 0 to 2 pi, we know it's going to be from 0 to 7 pi over 6. And then it's going to go from 7 pi over 6 to 11 pi over 6. And then it's going to go from 11 pi over 6 to 2 pi. So let me just plug into my calculator to get a decimal to see what value 7 pi over 6 is close to. So that's about 3.66 something. So let's plug in a 3 here. Let me do the same for 11 pi divided by 6. That's like a 5.75. So let's plug in maybe 5. And then here, let's plug in a 6. And we're going to go back to the derivative of our function. What's the derivative? 1 plus 2 sine of x. And I'm just going to plug that value in and see what we get. 1 plus 2 times the sine of 3. Make sure your calculator is in radian mode. I get a positive value. So I know that f is increasing. When I plug in 5 into the derivative, 1 plus 2 times the sine of 5, we'll probably get an, actually, you know what? No, I'm good. You end up with a negative value. F is decreasing. And then when I plug in a 6, 1 plus 2 times the sine of 6, you get a positive value. So our function is increasing. So we know that it's increasing on the interval from 0 to 7 pi over 6. And it's increasing on the interval from pi or 11 pi over 6 to 2 pi. It's decreasing on the interval from 7 pi over 6 to 11 pi over 6.